Precision. It means the reproducibility of a sensor. For example, if you were to take 10 measurements with a thermometer, precision would represent how close together those measurements were. Here's an example. So here we have some measurements. These represent inches of mercury, or our atmospheric pressure. If I had a barometric pressure sensor and I were measuring the pressure outside right now, and I bring it out there, read it, and I read 30.0 inches of mercury. Then I come back in and write it down. Then I go back outside and I read it again. And I read 29.8 inches of mercury. And I run back in and write it down. And I go about 29.7, 29.9, 30.0, 30.1, 30.0, 29.9. This is showing me that I do not have a precise instrument. And because these are very big changes. Just to give you an example, right now as I'm speaking, we're experiencing 30.0 inches of mercury for atmospheric pressure. If it starts dropping even down to 29.8, that means it's going to start raining. And if it continues to drop to 29.7 inches of mercury, that means we can expect a storm. So when we look at our readings that we took in a matter of 5 minutes, and we try to judge based off of what we know from atmospheric pressure, and you look at this data, you would see that, okay, it's a nice day out. Oh, looks like it's gonna rain. Now it's gonna storm. Now it's raining. Now it's nice again. So we see that this is not very precise. Precision is really just a representation of a certain type of error. So precision error we call random errors or noise. Here you can see two representations of precision. Up here we have our shots have been made all over the target. They are very random. So this is how precise they are. If you were to draw a circle around the outermost shots. Here's another example. It's a much smaller circle. So we can see that this person is a much more precise shooter than this person.